Good afternoon, everybody. Good to see a great turnout. Please continue to enjoy your lunch. I know we have some people in line, but we have a fantastic lunch program today, so we want to begin. Thank you for being part of the third Willcoxon Health Science Summit. It's a great crowd today. I've just been told we have 520 participants, so a huge turnout. And we do have a great program today. As always at the summit, we thank Willcoxon and the Willcoxon family for making this possible. It really is a great opportunity for our students, our faculty, and our community. So today we're going to have some presentations over lunch, and now we will hear from the Willcoxon Scholars. This is a group of Missouri Southern students who are participating in research projects under the mentorship of Missouri Southern faculty, made possible by gifts from the Willcoxons. It's a very special program. And I also want to thank Dr. Alicia Burris, who's on our faculty and serves as director of the program and mentors these wonderful students. This is the third year that students are supported in the research related to health and life science, and there are 5 different projects, and you will hear a brief presentation about each project. So I'd like to invite the first student to come forward and tell us a little bit about the research project.
Hello everyone, my name is Lily Rand and I had the honor of being one of the Willcoxon Scholars this year. My project is functional morphology of jaw adductor muscles in the common snapping turtle. I worked on this project with David Penning over in the biology department. First, a little bit about me. I'm a senior here at Southern who will be graduating in May with a degree in biomedical sciences on the pre-vet track. I'm hoping to go back to my home state and go to Iowa State University for master's or vet med programs following this. So a little bit more about my research project. So we studied the common snapping turtle, which obviously has a very strong bite force by its name. The really interesting thing about these animals is they're very small. This is kind of the average size of a snapping turtle head, and they can produce more bite force than a human can. If we bit down as hard as these guys, we would shatter all of our teeth and strain our muscles. So for them to do it on a common occurrence is very interesting. So we were able to send off 5 different snapping turtle heads for imaging. So we received backbone scans and CT images of these snapping turtles. So the top image there is running through a CT scan of the musculature system of a snapping turtle head. And then the bottom is a bone scan of a snapping turtle to kind of give you some visuals. Then we went and looked at the comparison of how these muscles are able to produce such strong forces and how they're to distribute that across their skulls to make sure that there's no damage done. This then can be connected back to human health by looking at different conditions that humans experience in their jaws with different kinds of strain and injuries. And so we can compare that back to hopefully come up with some new clinical options for jaw pain in humans.
Hello everyone, my name is Lisa Mufti and I'm grateful to be a part of the Willcoxon Scholars Program this year. I'm originally from St. Louis, Missouri, and I'm at Missouri Southern majoring in biomedical sciences as a senior in the MKeep program. I plan to matriculate into KCU this fall, and I'm currently interested in ophthalmology, so this research is particularly interesting to me because it allows me to explore my career passions and interests further.
Hi everyone. My name is Mai Dorgam. I'm also part of the MKeep program. I'm a senior majoring in biomedical sciences, and I hope to start medical school at KCU this fall with Eliza. This research is important to me because it actually was the one that started my interest in neurology and the nervous system and made me passionate about pursuing that in the future as a specialty. So first, we'd like to thank the Willcoxon Scholars Program for making this research possible. Our research is about exploring the presence and origin of catecholaminergic fibers, which are sympathetic fibers within the cranial nerves of the eye orbit, with the aid of Dr. Alaberry.
So to give you some background, sympathetic innervation is essential in regulating several ocular functions, such as pupil dilation, eyelid elevation, control of intraocular pressure and blood flow, and more. These effects are typically mediated by catecholaminergic fibers, which are Th-positive fibers that transmit sympathetic signals. When these signals get disrupted, this can typically lead to neuroophthalmic conditions such as Horner syndrome and other conditions. Previous studies have shown that Th-positive fibers exist in orbital cranial nerves. However, these studies have mainly performed a qualitative analysis of these fibers rather than focusing on quantitative analysis and exploring the potential origin of these fibers. Previously, MSSU students have contributed to our study by dissecting 12 orbits from 6 cadavers and extracting cranial nerves and fibers for immunohistochemical and quantitative analysis. However, we aim to add 2 cadavers and 4 orbits to the study, focusing on specific nerves that have previously shown Th positivity in order to gain a greater understanding and perform a more accurate quantitative analysis.
We hope that our study helps in clarifying the understanding of sympathetic anatomy of the cranial nerves of the eye orbit, which would hopefully contribute to both research and clinical use, such as in discovering novel therapies for neuro-ophthalmological diseases such as Horner syndrome, which currently does not have a cure, and also in decreasing the rate of complications in eye surgery. We also hope that it helps in establishing a framework for qualitative analysis for future orbital nerve studies.
So once again, our objectives in the study are to, 1, analyze previously collected samples from previous MSSU students who contributed to the study, and 2, collect new samples to quantitatively assess the presence, distribution, and potential origin of catecholaminergic fibers in orbital cranial nerves. We invite you to come to the back after our presentations in order to get a deeper understanding of what we're working on.
Thank you.
Good afternoon, everyone. My name is Kaya Gibson. I'm currently a health science major focusing in paramedicine here at MSSU. I will graduate this spring and I plan to apply to PA school. I currently am a full-time student and I have 2 PRN paramedic jobs, one way up in Jeff City and one here in Mount Vernon. I've completed this research under the guidance of my faculty mentor, Erin Tabor. She is the program director and clinical instructor of the EMS program here at MSSU. She is also a paramedic. So this project all started with the realization after working in EMS that as paramedics, we often don't arrive to the scene or to the moment an emergency happens. It is often everyday individuals, such as students, who may recognize an emergency, but often don't feel prepared to act. My research focuses on evaluating emergency preparedness, specifically in high school education, and identifying gaps in readiness and training. The goal is to help younger generations feel confident and capable in responding to emergencies. Because each year, about 350,000 cardiac arrests happen outside the hospital, and immediate CPR can double to triple the survival rates, according to the AHA. However, Missouri students only are required in high school to complete 30 minutes of CPR training. And this often does not include more common emergencies, such as seizures and allergic reactions. To explore this issue, I conducted a survey with 136 MSSU students to assess their knowledge, competence, and preparedness. My findings reveal clear gaps, but also opportunities to improve education and training. I invite you to come learn more about my research and how we can better prepare our future generations to respond to emergencies. Thank you.
Hello, everyone. My name is Sanvi, and this is my wonderful partner, Jayla. and we had the privilege to be a Willcoxon Scholar this year, which means we had the chance to research something we are extremely passionate about. So our research project was centered around the topic of antibiotic resistance. Now, antibiotic resistance is a threat not for the future, but one of us today. And I would like to ask you guys a quick question. How many of us know someone or have been prescribed antibiotics before? Now, that's almost all of us. So this makes this specific project of extreme interest to us as future clinicians. Now, antibiotic resistance is especially important because today bacteria are mutating at rapid rates, and we're using antibiotics with widespread usage, which means that we cannot produce as scientists enough antibiotics, and that's why we, as our project, tried to create our own special class of antibiotic resistance. It uses the same philosophy as other antibiotics on the market, targeting something bacteria have, but we humans don't. So specifically, our project targets the bacteria enzyme that synthesizes vitamin B5. Now, we all know we have to eat our vitamins, but what is so important about vitamin B5? Vitamin B5 is used in acetyl-CoA to synthesize acetyl-CoA, and that's the key. Acetyl-CoA is so important in the usage of lipid metabolism, making fatty acids, along with energy production. And all these three things, if we can poison that in a bacterial cell with a compound and not in the human, make for a great antibiotic.
So as you can see in our picture there in the middle, our research focuses on developing a mechanism-based inhibitor of the vitamin B5 pathway in bacteria. So in the natural process of synthesis of vitamin B5, there are several proton transfers that occur to get you to the final product. However, our antibiotic would feature a fluorine instead of a hydrogen on our compound, which blocks the deprotonation step and ultimately makes it so the bacteria cannot synthesize vitamin B5 at all, which effectively would lead to the death of the bacteria. So this is especially novel because there are no current antibiotics that feature this specific pathway. So we invite you to come back and see our poster to see the research that we've been doing on this. Thank you.
Good afternoon, everybody. My name is Gavin Wampler. I'm a senior here at Missouri Southern State University studying biomedical sciences, and today I'm going to talk to you guys about yeast a little bit. So over this past academic year, I've been working with Dr. Alicia Burris, and we've been studying a specific strain of yeast. It's called Petite, and these yeast have a altercation of their proteasomes, which make them unable to process unfermentable carbon sources. So in these strains of yeast, it was unknown previously if these yeast even had mitochondria, and if so, what did they look like? What was their relationship with other, or within the cell, if they had any like co-localization with proteasomes. So the goal of my study was to see, one, if these yeast had mitochondria, and if they did, was there any co-localization with the proteasomes? And what was the appearance or the morphology of these mitochondria? My future plans after Missouri Southern, I'm admitted to Oklahoma State University's medical school, so I plan to attend there next fall, and then after that I'm hoping to go into family medicine, where I plan to practice in my hometown of Jasper, Missouri. But finally, I wanted to give a big thanks to Ms. Willcoxon and the Willcoxon family for allowing us to do this. It's been great help to be able to focus on research for a whole year and be able to have a platform to talk about it with all you guys today. So thank you.
Well, thank you for those outstanding presentations. I think you get a sense of the level of research that's going on here and what students gain beyond their typical classroom and lab experiences, grappling with research. Sometimes things don't always work like they're supposed to, and that's part of the process. And I also want to thank the faculty again for serving as mentors for these students. Let's give our students a round of applause again.